Hi, everyone. Thank you for joining us. We will get started in a couple minutes. So feel free to grab your coffee or tea and come back. Hi, everyone. Thank you again for joining us. We'll get started in 30 seconds or a minute. And while we kind of wait for folks to trickle in, I want to cover a couple of housekeeping items. First, the session is being recorded and will be shared with all the attendees. Second, feel free to submit your questions in the Q&A panel. We'll try to answer some of the questions in the session, and we'll leave plenty of time at the end for live Q&A. All right, let's get started. So today we'll talk about how Splunk, specifically Splunk Observability Cloud, and ThousandEyes together will help you correlate front-end application and network data to help you troubleshoot faster. And let's meet our speakers. So Antonio, do you want to kick us off?
Thank you. Yeah, for sure. This is Antonio, working in ThousandEyes as a tech lead of the streaming team. So our goal is to integrate with other platforms like Splunk and also stream ThousandEyes data to other platforms using OpenTelemetry. Nice to meet you all.
Hi, everyone. This is Akshat. I'm the product manager in the Splunk real user monitoring team. My focus is on primarily browser real user monitoring, as well as some RUM platform initiatives. And I'm going to cover the RUM ThousandEyes integration later in this tech talk. And I'll hand it over to Wei.
Yeah, hi everyone, my name is Wei. I'm a principal product manager at Splunk focused on observability. I've worked on various observability products at several companies now, still passionate about this space. I'm very excited to have this discussion with everyone. So the plan for today is we are going to focus on the two out-of-the-box integrations we have between ThousandEyes and the Splunk Observability Cloud. So the first one is the ThousandEyes integration with Splunk Application Performance Monitoring, APM. The second one is the ThousandEyes integration with Splunk Real User Monitoring, RUM. And before we dive into these integrations, we would like to actually give you a quick overview of what is ThousandEyes, what is Splunk APM, what is Splunk Real User Monitoring, just to help set the context and get you familiar with these capabilities. We've also prepared 3 exciting demos throughout the webinar to help you see the product in action. And finally, as I mentioned, we'll have plenty of time at the end for live Q&A. So feel free to drop your questions in the Q&A panel. OK, before we actually dive into the content, we want to do a kind of quick check here. We are curious to understand what products do you use in your organization today. Do you have Splunk APM, Splunk RUM, maybe ThousandEyes? Or if you don't have any of these and you are here to learn about these different solutions, which is perfectly fine. So if you have a second, please let us know your answer. And this will help us tailor our content to the audience. Yeah, I'll give another 10 seconds and we can check out the result. Okay, great. Yeah, okay, we have an interesting mix. Okay, some APM, some ThousandEyes, some RUM users. Perfect. Yeah, and don't worry if you are new to any of these, we are going to cover all of them today. Okay, so I would like to actually start with a quick overview of ThousandEyes. ThousandEyes does a lot, but today we are going to focus on its network and application synthetics. Many of you know synthetics as a practice of simulating user traffic from distributed locations to measure application performance. But what really differentiates ThousandEyes from other synthetic solutions on the market is three things. First, global vantage points. So over the years, ThousandEyes has actually deployed over 1,000 cloud agents across the internet, including internet service providers, cloud regions, internet exchange points. This means that you can basically test any path your user take and detect issues from anywhere in the world. So this is, I would say, something that's very difficult for most organizations to replicate on their own. And in this sense, I would say ThousandEyes probably provides the broadest coverage on the market. Second, ThousandEyes also provides deep network insights. So beyond your basic, is my application up or down type of checks, ThousandEyes also shows DNS resolution, BGP routing views, hop-by-hop network path realization, along with your typical network metrics, such as packet loss, latency, jitter. This actually allows you to detect any network paths and the internet routing issues that other synthetics miss. So for example, yesterday, we know a lot of applications went down because of a cloud provider outage. If you had ThousandEyes, ThousandEyes would have actually helped you immediately kind of visualize how the outage was affecting your applications, because ThousandEyes actually shows the hop-by-hop network paths between your applications and end users. And also to kind of double-click on this, here is a list of test types and metrics that ThousandEyes supports. These tests are organized by layers of operation. So the routing layer tests, they measure metrics like routing path changes, reachability, BGP updates. The network layer tests, they look at your network metrics, packet loss, latency, jitter. ThousandEyes also provides DNS layer tests that will look at domain availability, resolution time, domain trace. And of course, also web layer tests that look at application metrics like availability, response time, throughput. Also, ThousandEyes provides voice layer tests that look at things like SIP registration, RTP, stream metrics. So as you can see, ThousandEyes actually provide very comprehensive coverage across your application, network, and internet routing layers. My last point here is ThousandEyes doesn't just collect the data, it actually helps you correlate the data across these different layers to provide you with full context and help you be able to actually isolate the problem. To give you an example here, so in ThousandEyes, we have the concept of layered tests. So if we run, say, a web layer test, such as an API test, it would actually automatically incorporate DNS network and the routing signals in one view, so you can actually see performance in full context and quickly, say, isolate the problem domain to either network or internet or the application layer. So that's actually pretty magical. With that, let's actually now see a quick demo of the ThousandEyes. Over to you, Antonio.
Awesome. So yeah, thank you for the great explanation. Let me share the screen. All of you understood what ThousandEyes is. So now let's jump into our platform. So here, I think now you can see the screen. Here you can see how ThousandEyes platform look like. We have like dashboard, different events, which is a group of alerts. We also have like network and app synthetics. Those are the famous ThousandEyes tests that Wei was mentioning before, but not only those, we have also endpoint that could be running from a local computer or from your phone. We have also BGP, traffic insight, cloud insight, internet insight, and many more. This is like the main picture, but let's go now to two examples where really explain the value of ThousandEyes. Those are two snapshots that explain a problem that happened in the past and how to understood. Wei mentioned before that yesterday we suffered a AWS outage. This is also an outage that happened in 2018, similar one. So here we have a ThousandEyes test that is monitoring that web page, an EC2 instance in Amazon. And we have agents all around the globe, from Seattle to Tokyo, Zurich, London, and so on. And then here in the maps, we can see that we have agents which are working perfectly, except on that area. So we have that area, and we also have Charlotte. Let's try to understand what's going on that place. So HTTP server have an availability drop. So let's choose Charlotte to see what's really the problem. Here we can confirm that the availability is 0% in that time. But not only that, we go to the network side and we can see loss and latency. Loss percentage is 100 and latency is 0, which means that there is not even latency. So if now we go to our agent to server layer that we mentioned before, we can see our path visualization that go from that agent to our destination, our target. And we can see here that red circle that say 100 packets loss. We have Augsburg, Virginia, it's losing all the packets in that network provider and that AS. We can confirm that the problem was similar to the one that was happening yesterday, where we couldn't reach our Amazon application in that region. We can confirm that the rest of the agents looks fine around the rest of the world. So we have like Russia, Seattle, Zurich, all of them were properly reaching except the one in that area. So this is an example, as I mentioned. Let's jump into another example where we can identify a network issue. Here, this is a page load test where we are monitoring that web page. We can realize that our page load time is moving from around 1,000 milliseconds to 2,000. It's kind of doubling, but we don't know yet what the problem is. So now if we check the rest of the metric like response time, we also add latency, we can also add page load. So we have those three. We can identify that the response time is increasing, which is on the HTTP server layer. But not only that, the latency is also increasing, which gives us a hint about the problem. So here we go from 80 milliseconds to 65 milliseconds. Let's choose an agent to understand better. For example, London. In the London agent, we can confirm that the problem is still there. Now, if we go to our agent to server layer, we can see that London is reaching our web page through that hop. If we go to a scenario where it is working fine, we can see that in the last hop, it's going through Luxembourg, and it's taking 15 milliseconds. However, when we are going through, when we have the latency problem, it's not going through Luxembourg, it is going through Las Vegas, and it's taking around 148 milliseconds. So we can confirm that the problem is like the routing is not efficient. It's taking a longer route to go to our web page. The issue was solved, but we were able to identify the root of the problem was network, and the root of the problem was how it was routing through Las Vegas instead of Luxembourg. I hope you understood the X scenarios, and now all over to you. Thank you.
Yeah, thank you, Antonio. That's very helpful. We'll come back to ThousandEyes UI in a little bit. But now we've learned a little about ThousandEyes. Let's also talk a little about Splunk APM. So Splunk APM is probably one of the best open telemetry-based APM solutions on the market. And it stands out in 3 ways. First, we help you correlate metrics, logs, and traces across your entire stack, including the front-end, application, and infra layers. This means that you can trace say, an alert on your application front end all the way to the root cause in the infrastructure, such as a misconfiguration in your Kubernetes workload. And many of us, we know that this level of correlation is absolutely critical for today's very complex distributed applications. And that's the first step. Second, we actually help you turn that data, that visibility into actionable insights. The feature I want to highlight is Tag Spotlight, which is my favorite feature within APM. I actually have a screenshot here, which may be difficult to see. The idea is Tag Spotlight would automatically group your traces by shared attributes, such as environment, host name, service version, operations. And then we actually surface the red metrics like request rate, error rate, duration for each group of traces. This type of visualization actually allows you to quickly find patterns in your traces. You will be able to quickly see what your problematic traces have in common. Then you can drill into those traces to pinpoint the root cause. So this is a very intuitive, very intelligent way for root cause analysis. We don't have time for like a live demo of APM today, but when you have a second, definitely check out APM and the Tag Spotlight. Finally, we are very proud to provide the best-in-class support for OpenTelemetry. So as many of you know, Splunk is the #1 corporate contributor to OpenTelemetry, and we provide very comprehensive support. So in terms of data collection, we provide a vendor-neutral data pipeline. This means that you can instrument your application with OpenTelemetry, deploy your OTL collector, then you are finished with your instrumentation. Later, if you want to switch backends, you can simply point your OTL collector to another OTLP-compatible backend without re-instrumenting your code. So that's the data collection piece. In terms of data analysis and visualization, our product experience 100% follows the OTel semantic conventions. So if your developers are already familiar with OTel data model, they can quickly ramp up on the product without needing to learn a new data model. So this helps save developers time and help avoid vendor locking. So ThousandEyes is great, Splunk APM is great. Let's talk about the power we can unlock by integrating them. And I actually have a question for everyone. Let's say we run a synthetic test, and the result comes back and shows a potential performance issue in the application. How should we investigate the issue? Option A, we can poke around the system, hoping we find something interesting. B, we ask in the developer Slack channel and be told that Bob is on vacation for the next 2 weeks. C, we can investigate the application telemetry data from the same time I ran the test. So what do you think? I think we know that we want to investigate the application telemetry data, but it's not always easy to do that. Debugging fail tests is actually very difficult when your black box data and the white box data don't align. So what do I mean by that? Well, with synthetic testing, we are actually performing a type of black box testing, meaning they take your test data as input, and then they output some high-level performance metrics, such as latency. While these metrics can surface a performance issue, you still need to look inside your application and infrastructure to find the source of the problem. So a lot of times we actually have to pivot between multiple siloed testing and monitoring solutions to correlate the data in order to kind of pinpoint the root cause. This is time consuming, this is very manual and very brutal. And that's actually why we built the ThousandEyes and Splunk APM integration. So what we are doing here, we are actually correlating your ThousandEyes tests with Splunk APM traces to help you quickly debug failed tests. And it works in a few steps. So first, now you can easily launch your tests from the ThousandEyes UI for any Splunk APM instrumented services. Second, you can quickly see if the slowness is coming from the network or the application layer. If it's an application issue, you would be able to see the relevant trace topology and then drill into the span details to pinpoint the root cause. So this means that you can basically go from launching a test in ThousandEyes to pinpoint the root cause in just a few clicks. And also because this integration is bi-directional, so you can actually move seamlessly between your ThousandEyes tests and the Splunk APM traces without losing the context. If that sounds interesting, let's actually check out our second demo. Antonio is going to show the integration in action.
Let's do it. Yeah. So let me share the screen again. And here you can see. So here, what do we have? We have a ThousandEyes test that is monitoring that endpoint. That endpoint needs to be able to receive OpenTelemetry headers, traces, and also that endpoint is instrumented with OpenTelemetry and is sending the data, in that case, to a Splunk Observability Cloud. That is a requirement for our use case. Now we are monitoring that use case, that endpoint from a network perspective. So we have our agent to server, so we see like no loss. We also have like latency, jitter. So we can see that it is super stable. We can see our agent in Paris reach the destination without any problem. There is not a single network scenario with a problem here. But if we go to HTTP server where we were before, we can see that availability is going up and down. So for sure, there is a recurrent problem that is our customers are hitting from time to time. So now there is that new tab called Service Map. That Service Map, what it's doing is getting the trace ID from that request, calling a Splunk, giving me the trace from that trace ID, and we are representing in ThousandEyes as a really simple service map view. Here we have our ThousandEyes agent calling our entry point. So here I want to show you the request that we are doing here is nothing else than API test and then our host name, which is nothing else than our endpoint here. So host name and then API test. Remember, this is an endpoint that we created for the demo. So this is our entry point, and this is calling a variety of different services, like it could be using gRPC, HTTP. In that example, is using HTTP. Here you can see HTTP status code 200. It is a GET operation, calling that URL path. And we even can call a database, like in that case is Postgres, and we can have several requests. Each request we are going to have the different statement, like a select or something. All of this is provided by OpenTelemetry. As we mentioned before, we are a huge contributor for the ecosystem. Now, but let's jump into a scenario where it is failing. So we can go to the specific agent Paris. We can select that region, for example, and then we go to a scenario that is having a availability drop. And we're going to see the trace in that scenario. Here we can see that from our ThousandEyes agent, we have a request that have an error, availability 0%. And we can see that it is still as before the same URL, but now there is a status code 500. So that give us a hint that there is a application problem. If we also go to that specific request between main application and product catalog, we can see that the status code is error. But not only that, we can see exception message internal server error. We can see also status description, runtime, and we can see our 500 here. HTTP response status code 500. We can confirm that there is not any single network issue. This is an application problem. As we mentioned before, we have a capability to jump into a Splunk and see the actual problem. Let's do that. Now we jump quickly into a Splunk, and we link it directly to our Splunk instance, to our trace that we were looking. Remember, we were in a trace finite in 04. We are in the 04, perfect. And now this is our dissident tracing, as you are more familiar seeing. And here we can see that there is an actual exception stack trace. That exception is happening on product catalog app Python in that line. And the problem is like there is a runtime exception, internal server error. We can confirm this is a problem. We can create a prepared Jira ticket to having the team to fix it. What things that integration is providing to us? We have a bidirectional integration, which means that we can go from Splunk into ThousandEyes just by clicking into go to ThousandEyes, and that will jump exactly into that specific round for that specific test and for that specific user and account. Everything well synchronized. You can reach that point from there, or even if you have that clause, you can also reach it from here, view in ThousandEyes. Not only those, we have now a subset of new attributes, which are ThousandEyes account ID. So you know which account is doing that request. The permalink, so you know how it's linked to ThousandEyes, your agent, the agent ID, and also your test. You might be thinking why they are useful. For sure to know which one is the origin of that request, who is doing that request, it is ThousandEyes, a synthetic test. But not only for that, if now I go to our, I hope all of you are familiar with our trace analyzer, you can go there and filter by that attribute. I want to filter by test ID, ThousandEyes test ID, and then I put my test ID. This is going to provide to us all the traces coming from ThousandEyes synthetic test. And this is quite useful, not trace found. Okay, that's interesting. It's because I choose the wrong one. Give me a second. We are going to fix it soon. Test ID. Here it is. And then I put my test ID. It will appear all the traces that are related with that ThousandEyes synthetics. Here you can see the same as before. You can see that sometimes it's works, sometimes it's fail, and when it's fail, you have that exception. And when that works, that have the happy path that we mentioned before. Perfect. So now you understand the integration. Let's now see how you can build that integration. You're going to need to go under Manage, Integrations, Integration to Zero, Connector, New Connector. You select New Connector, and here you're going to put, we're going to create one for the session, webinar, and then we're going to put our target. Our target is going to be our Splunk instance. In that case, for me, it was app US1 signal effects. So let me put it there. And now I need to put a preset configuration. I choose Splunk Observability APN that have that custom header. And then I'm going to put the header. As all of you are familiar, we have access token in Splunk. So let me create one quickly. So create new token, webinar. Remember, that needs to be API because we are doing an API request. So I click next, next, generate. Now that's generate my webinar. Here should be, and then I copy it. Perfect. And now I paste it here. So I go to next. I create a new operation. That operation is going to be a Splunk Observability APN. I put a name, webinar, and then I create it. Let me associate it with the connector. Perfect. Now we created our integration. Now let's create a ThousandEyes test with distributed tracing enabled. That's the main key part here. So when you create a ThousandEyes test, we go to start monitoring. We go to HTTP server is a test that supports that integration. HTTP server. And now we're going to put our URL that we were using before. That's the URL that we are using. Why it have a problem? Let me copy from the existing one. Sorry for that. Service map demo. Let me copy. Okay, now it's work. I mind there was some character. We put the interval, it could be run any minute. We select an agent. Let's select, for example, London, England, IPv4, close. And then no alerting. You can put alert, but not for that use case, webinar. And as I mentioned, the important part is when you create it, you select enable the student tracing. Enable the student tracing to true, and then deploy. You click on checkout test result. That is going to take around 1 to 2 minutes to start generating the data. And we need time also to check and get the service map from Splunk. But this test is nothing different from the one that we have. Something else that I want to highlight to you, how we are doing that interception about Splunk and ThousandEyes based on the trace. We are injecting, as you can see in the request header, we are injecting the trace parent with a trace ID. So as ThousandEyes is the one setting that trace ID, for sure we know which one is the trace that we want to query from Splunk. We are also using the concept of trace state, where we are setting all that metadata that we talked before, like from the permalink, the account ID, the agent ID, test ID, and so on. This is the way how the integration works, and this is how we are using it. Thank you so much. I hope the demo was useful. All yours now, wait.
We'll pass on to Akshit to talk about the next integration.
Thank you so much. I think you're mute, Akshit.
Oh, yeah. Thank you. Thank you, Antonio.
That works.
Thanks. Yeah, so now I'll cover Splunk real user monitoring and how we integrate with ThousandEyes to unlock value for our customers. But before going to the integration, just wanted to give a brief overview of what real user monitoring is. So our real user monitoring product in Splunk complements the APM product and provides insights into how end users are basically experiencing your browser or mobile apps. So say with real user monitoring, you could answer questions like, are users facing latency issues while logging in, or while checking out through your application, are users facing any errors? So any end user experience issues, could be latency, could be errors, are addressed and could be understood through our RAM product for both browser and mobile apps. So some of the key pillars that I wanted to highlight about what RAM does is, one is, basically the ability to understand how users are experiencing your website